method we will learn the trick to analyze any AC circuit given to you. If you have any AC circuit question in the paper, you have to make sure that you follow these steps, you won't go wrong. So remember, let me take an arbitrary circuit. So you know this RLC, you can have as many number of C's, L's in various positions, but I've taken this particular where I have one L, one C, one R, and they are placed like this. How do you solve this particular problem? Remember, replace your C with 1 by j omega C. I'll tell you what J is, I'll tell you what omega is. Remember, this omega and this omega that I'm trying to replace with should be same. Replace C with 1 by j omega C, will replace L with j omega L and keep R as it is, right. So let's see, after these replacements what will happen? You'll have R like this, and then you'll have 1 by j omega C like this. In fact, make them impedances, as I would say, don't even show them as capacitances anymore, right. So you have 1 by j omega C like this, you have R like this, and you have j omega L like this, right. And then you have V naught sine omega t. Now, what do you mean by 1 by j omega C? Any quantity, if it's on the real axis, this is your real axis. Remember, they are all complex numbers. This j is nothing but your iota, right. Any real quantity, say A, if I say JA, that means I am shifting this quantity on the y axis. So this is how my JA will look like, right. So 1 by j omega C can be also said as minus j by omega C, because you multiply with j on top and bottom, j into j will be minus 1 because j is under root minus 1, and you will have a minus j on top. So what do you mean by minus j by omega C? Something like this, right. So this is your 1 by omega C. Minus j by omega C means 1 by omega C downwards. Omega L multiplied with j, that means your omega L is like this, right, and your R is like this. Now you will have to calculate the net impedance here, right. You have R and 1 by j omega C. So your net impedance in this part is nothing but Z net here in this part is nothing but R into 1 by j omega C divided by R plus 1 by j omega C. This will be your Z net, right. And if you need the entire impedance Z total, then that will be nothing but Z net plus j omega L, right, plus j omega L. Now you simplify this, then you will have something like a plus jb form, right. You will have something like an a plus jb form, wherein what does this mean? So what I am trying to say is just, you know, take this j omega C that side, take it on top, cancel it, and then add j omega L, and then finally convert it into this form, a plus jb, right. That means your impedance is also a complex number now. Your impedance is a complex number which has real component A and imaginary component B, and this will be the impedance angle theta, right, impedance angle theta. Now if you need the current in the circuit, what you will do is I is nothing but, just like your voltage is peak voltage into sine of something, your current will be peak current into sine of something. So peak current is nothing but peak voltage divided by peak impedance, that means the magnitude of impedance Z total mod Z total, that's your peak current, and you will multiply this with sine of omega t minus angle of impedance. Remember, minus angle of incidence, don't do plus angle of incidence, you have to do a minus angle of incidence. That's how you will get the current phasor. So our goal was to get current as an alternating function. We have done that successfully. First we need to find the impedance using this trick, using these tricks. Wherever you see C in the circuit, replace that with 1 by j omega C. Wherever you see R in your circuit, replace that with j omega L. Keep your R as it is, and then treat them as impedances, wherein like these two are in parallel, that is, and then this entire thing is in series with that. Calculate that, get your impedance as a complex number, right, and then get the angle of impedance using B by A, tan inverse B by A, right, and use that angle here with a minus sign to get current, wherein your peak current is V naught by magnitude of this complex number. That's how you analyze any AC circuit given to you.